So let me draw this out real quick. So if I have okay, so we'll label this L, this will be M, this will be T, or no, this is N. And so what they're saying is, if this is perpendicular to this, and these two lines are parallel, then what can we conclude from that? That N is perpendicular to M. Does that make sense?
So would that stuff that the if already be like given to you probably?
Yeah, really what we're going through, and I wish that this was more like a college level geometry class, because then I would actually show you a little more formally how to prove it, but you guys just kind of have to memorize it, right? Does that make sense? What we would have to do is we would say, well, how do I know that? Well, because these two lines are parallel, basically we know that the corresponding angles are congruent, right? We could prove that. And what is this angle? Well, this angle is 90 degrees. So if this is 90 degrees and this is 90 degrees, then because of linear pairs, this is 90 degrees and this is 90 degrees. But now we have this linear pair from here to here. So these are 90 degrees and this is 90 degrees. Vertical angles, linear pair, however you want to say it, corresponding, all of those angles are 90 degrees. Proving the relationship between lines. Uh-oh, this one looks pretty weird. So, whoops, wrong one. What the heck, we'll just leave it up there. So we have a line like this, we have a line like this, a line like this, a line like this. Okay. And this is line A, this is B, this is C, and this is D. And we know they're lines because we're going to draw these little arrows like it is in the textbook. And then your textbook even tells us, there's some information. It says in the plane, C is perpendicular to B. So somewhere, I'm going to do this. This is given to us. All right? And if it's perpendicular there, then it's perpendicular here, and it's perpendicular here and here, right? Because of the linear pair relationship and vertical angles. Right? This angle here plus this angle here is 90, right? 90 plus 90, which equals 180, right? And that is a linear pair, and we could do that all the way around. Next, they tell us, so this is given to us. Next, they tell us that B is perpendicular to D. So, again, we're going to go to B and D where they intersect. Boom, 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 boom. All right, that's cool. Now, right off the bat, before I go any further, what do we know about D and C?
Parallel?
Yeah, D and C are parallel based on what theorem? 3.9. If in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Right? So if two lines are perpendicular to a transversal, then they are parallel to each other. So I'm going to do this. These two are parallel. Okay? C and D are parallel. All right, so we're not done with the givens, though. Then it says that D is perpendicular to A. All right, so then this is perpendicular, perpendicular. So now A and B are both perpendicular to D, so what does that tell you about A and B?
They're parallel too.
They're parallel too. So now I'm going to make two arrows. That's 1, 2, and then 1, 2. Okay? But we're not done. Then it says that C is perpendicular to A. Well, they don't intersect, But that makes sense, right? Well, they would intersect if I continued to draw the line. Oh, I said to prove. I'm sorry, I misread the book. So this is what they want us to prove. So this is our given, and they want us to prove this. Well, if A and B are parallel, you could do the, wouldn't you do like kind of the converse, right? If A and B are perpendicular, or if A and B are parallel, and C is perpendicular to B, what does that tell you about C and A?
That C is perpendicular to A. If they intersect, which they would, if the lines are kept on drawing.
Yeah, and, or an easier way, it says, this is what your book says, it says, therefore, well, let me just read it. It says, line C and D are both perpendicular to line B, so C is parallel to D, we mark that. Because these two lines are perpendicular to the same, they are parallel. It is given that D is perpendicular to A, therefore C is perpendicular to A, because the line that is perpendicular to one of these two parallel lines is also perpendicular to the other. And it's called the perpendicular transversal theorem. In other words, what they're saying is, because D is perpendicular to A, right? In other words, they're saying because why can't I spell the word because? A is perpendicular to D, and C is parallel to D, right? Then C is perpendicular to A. And so what I would do is I would imagine extending this line. So as I extend this line, this is going to be perpendicular. Why? Because they're parallel. Because C and D are parallel, and A is like a second transversal. So if A is perpendicular to D, it will also be perpendicular to any line parallel to D. Does that make sense? And since C is parallel to D, well then A has to be perpendicular to C. Take the statement P, lines are parallel. I guess there's nothing stopping me from doing it. And then Q would be lines are perpendicular to transversal. Okay? So P implies Q. What does that say? If the lines are parallel to, well, if the lines are parallel,
Then the lines are perpendicular to the transverse.
to the same transversal, right? Which one was that, 3.9 or 3.10? Huh?
10.
3.10, I believe, right? So this is really 3.10.
Yeah, I would say.
Now, if I were to write Q implies P, what am I saying?
Then if the lines are perpendicular to the transversal,
Yeah, if two lines are both perpendicular to the transversal, then
they're parallel.
they're parallel. Which one was that? 3.9.
Yeah.
3.9. Now, what Mr. Adams is saying, this is a one-way implication, right? A biconditional statement would just be this. I could say it like this. P implies Q, or Q implies P. Now, if I wrote it that way, what would we say?
If
If and only if the lines are parallel, then the lines are perpendicular to the transversal. And that means that the validity, in other words, if this is true, then this is true. It goes both ways, right? Okay.